Alright, how's it going, my pre-cal students? Working on our review for the unit circle test. We'll go ahead and just jump right in. It says use formulas to convert between degrees and radians. I mean, it really is both ways. We're given degrees and radians, and we're trying to just go from one to the other. Make sure that you're leaving everything in terms of pi, so that you're not just multiplying by like 3.14 or something like that. We want to leave it in terms of pi, just like most of our radian measures are. So there's two formulas we could use here. If we're going from degrees to radians, that one is pi over 180. That's our conversion factor. Okay, and if we're going from radians to degrees, we just flip it, and it's 180 over pi. Okay, it's just like half a rotation. So over here we're given radians because it's in pi, and so what we would do is we'd multiply by 180 over pi. Okay, we can just go ahead and do that. 180 over pi. What's nice about this is we can just go ahead and reduce our fractions here. So let's see, that would be 180 divided by 9 would be 20. So 20 left here and 1 left there. So then we would have 20 times 11. Let's see, that would be 22. Well, 220. And then the pi's also cancel. So we're left with just 220 degrees. Okay, so that's how we go that direction. Over here we got number 3. We're given 200 degrees, so we're going from degrees to radians, so we got to use this other conversion factor here. So this would be multiply by pi over 180. And remember, if it's not a fraction, we can just kind of put it over 1. So it's like we're multiplying fractions together. Okay, they both have a trailing 0, so we can get rid of that. They're both even, right? 20 and 18, so I can divide both of them by 2. So 20 divided by 2 would be 10. And then pi, and then on bottom 18 divided by 2 would be 9, so that one would be 10 pi over 9. And again, you're leaving in terms of pi, so we're going to leave that guy right there. Alright, these here, we're finding the sector. For sectors of circles, we got two formulas: the arc length, so that's S equals r theta, and we got the area of a sector is 1/2 theta r squared. So for this one here, it says the sector of a circle has a radius of 10 centimeters and a central angle of theta equals 2 radians. Find its arc length and area. So what I would want to do here is, first of all, I like to draw the situation. Okay, so we got some sector here, and the theta in here, this angle, is going to be 2 radians. Literally just the number 2. Okay, the radius is 10, so these radii here are both 10. So we're just going to use our formula. So this sector, its arc length is r theta. So what we have is our radius is 10, and then our theta is 2. So we'll have 20. Don't forget your units. This was in centimeters, so that's 20 centimeters. So that's the arc length. The area of the sector, so when we say arc length, we're talking about this part of the circumference. We're talking about the area of the sector. What we're talking about is like how much of the piece of pie we have or something like that. So that'd be 1/2. My theta is 2, and then my r squared, that'd be 10 squared. Okay, so this would be equal to 1/2 times 2, those cancel, and then 10 squared is 100. And since this is area, it'd be centimeters squared. Just like that. Okay, the key to these ones is to make sure that your theta is in radians. Okay, to use these formulas, the arc length of the sector and the the area of the sector, you got to make sure that your theta is in radians for these formulas to work. If it's in degrees, you got to convert it over by using the techniques up here. Okay, we'll leave the rest for you guys there on those. Okay, so down here in section 3, just as evaluate using the unit circle. So basically what that means is, like, find the value, right? So we'll just pick some random ones in here. Cosine of pi over 3. Cosine of pi over 3. Cosine is the x value at the angle pi over 3, which also happens to be 60 degrees. Okay, so we're looking at the x coordinate at pi over 3. Well, that would just be 1/2. Okay, just remembering our unit circle, guys. We're here. We can do a little brain dump of our first quadrant here. So 0. Let's see if this is our theta. Then 0 would have the point. It'd be 1, 0. And then the tangent would be 0, right? So here's our cosine theta and our sine theta, and then this will be our tangent theta. Okay, so if we have pi over 6, that one is √3 over 2 and 1/2. And then our tangent theta will be √3 over 3. Okay, we got pi over 4, √2 over 2, and √2 over 2. And then that guy is 1. Oh, we'll just move it over here. Pi over 3 is 1/2, and then √3 over 2, and then its tangent is √3. And then, let's see, let's do pi over 2 as well. It'd be 0, 1. And so then this one would be undefined. Okay, so there's our little brain dump here. So we have that as we're kind of going through these ones. Let's see, I'll just pick a random one here. Let's say cosecant of 180. That's interesting. So cosecant, we don't see that in our brain dump, but if you remember, cosecant is the inverse of sine. So really what we want to do is find sine of 180, and then what we'll do is we'll take the inverse of that. So sine of 180, that would be 0. Okay. Now, when we're flipping 0, really it's 0 over 1. So when we flip it, we actually ended up, to get our cosecant, we flip it, and we get 1 over 0, which is undefined. Okay, so that's how we do our inverse trig functions. So we can kind of write those off to the side over here. Well, right, let's put those up here or something. There's got to be room here somewhere. What about right here? Yeah. So cosecant theta is really just 1 over sine theta. Let's see, what else is there? There's secant theta, that was 1 over cosine. And then cotangent theta, that one's 1 over tangent. Okay, so there's those. Those kind of help us out. Let's see. It's like cotangent of 135. Really what we want to find is cotangent is the inverse of tangent. So if I find tangent first, then that should help. 135, that's 3 pi over 4. So we're talking about second quadrant. So tangent is going to be negative. Okay, so this is going to be negative. And then this is a over 4 family. So if I go over here, my over 4 family has a tangent of 1. So that's going to be negative 1. Okay, so then really that's negative 1 over 1. So if I flip that, for this one, it would be 1 over negative 1, which is still just negative 1. Okay, so that's going to be that one. Let's see. Sine of 11 pi over 6. Let's just do the random one right below it. It's the over 6 family. Over 6 family and the sine, so that would be the y coordinate, so it's going to be 1/2. But then 11 pi over 6 is in the fourth quadrant, and sine is negative there, so we'll go ahead and make it negative 1/2. Let's see. How about cosine of a negative 90? What's nice about cosine is even. So that means that cosine of negative 90 is the same thing as cosine of positive 90. That's what I like about cosine. Okay, so cosine of positive 90 is actually 0. So it's going to be 0. Let's see. What else do we got in here? We can do something different. How about this one? Sine of 9 pi over 2. 9 pi over 2 isn't one of our special angles. In fact, it's actually bigger than 2 pi, and 2 pi is one full rotation. So what we need to do to 9 pi over 2 is we actually need to take away full rotations. So 9 pi over 2, we need to take away 2 pi. But 2 pi is actually 4 pi over 2 as a fraction. Okay, so this is actually 2 pi here. So this is going to be equal to 5 pi over 2, which is still bigger than one full rotation. So we're going to take away 4 pi over 2 again, so that we end up with just pi over 2. So really this sine of 9 pi over 2 is really sine of just regular pi over 2, which that's just equal to 1. Okay, and that's kind of how these ones go. You're just evaluating them. Make sure you got some kind of brain dump. Would be very helpful for this test. Something like this, I mean, this would work where you can actually draw out, a unit circle and put in the values that you want on there. But this test really, really, really needs some way of remembering some of these key features, and maybe even some of these inverses here too. That way you can use that as a reference as you're going and you're not having to memorize as much. So having some kind of brain dump is very helpful. Alright, I'm going to skip ahead to section 4 here. It says find the exact value of each expression. And so the idea here is that we're finding the values, like we're evaluating like what we were doing in the one prior, but at the same time it turns it into an expression. So like this first one, cosine of 180 minus sine of 90, I can find cosine of 180, that's just -1. But then I want to subtract from that whatever sine is of 90. Well, sine of 90 is 1. So that means that this is -1 minus 1, so it's going to be -2. So it's just evaluating the expression. Okay, let's see. I'll just go ahead and do 30 just because I can. So 5 times cosine of 90, well, cosine of 90 is 0, so it's going to be 5 times 0. And then minus 6 times sine of 270. Well, sine of 270 is -1. So it's going to be 0, and then -6 times -1 would be +6, so that would be 6. It's just evaluating the expression. Alright, continuing on. Flipping over to section 5 here. We've got a point. XY on the terminal side of angle theta is given. Find the exact values of each of the trig functions of theta. Use X, Y, and R formulas. So our X, Y, and R formulas are sine theta equals Y over R. Let's see. Cosine theta equals X over R. And then we've got tangent theta is Y over X. So then that leaves cotangent theta is X over Y. We've got cosecant theta, which that'll just be this one reversed, so that's R over Y. And then we've got secant theta, which will be R over X, which is cosine reversed. Okay, so what we're given on these ones is we're given actually a point. So I always like to draw out the situation so that I can better understand it. +3 and then -4. So we're going to be somewhere down here. These pictures don't have to be perfect. It's just getting an idea of where we're at. Okay, our theta is right here. It's a right angle. 3 is my x, -4 is my y. So that's my x, that's my y. So R is right there. Okay. We need to figure out what R is. Well, we can use x squared plus y squared equals r squared, essentially the Pythagorean theorem. But we also know our special triangles. We got 3, 4, and then that would make R 5. Okay, so that would be a 3, 4, 5 triangle. So now that I have x, y, and r, I can find all 6 of these trig functions. So like in this case, sine of theta would be y over r, so that would be -4 over 5. Cosine of theta would be x over r, so it would be 3 over 5. Let's see, tangent theta. That one would be y over x, so it's negative 4 over 3. And then let's see what else we got. Cotangent theta is x over y. And then we've got secant theta would be r, which is 5 over x. And then last we've got cosecant theta, which would be r over y, just like that. Those are the the 6 trig functions that would go along with that point, all right, for this theta that would be created with the x-axis. Remember that theta is always with the x-axis, okay? Along the same lines, this says name the quadrant in which the angle theta lies. So each one of these we're talking about a different theta, and we're trying to figure out where each one of these angles is going to be. Is it going to be in quadrant 1, 2, 3, or 4? Okay, and if we remember, everything is positive in the first quadrant. So that's why we say all, and then students take calculus. So all of them are positive here. Sine is positive in the second quadrant. Tangent's positive in the third quadrant, and then cosine is positive in the fourth quadrant. So over here, if we just look at this first one, cosecant goes with sine, right? It's the inverse of sine. So this is really saying sine of theta is less than 0. And then tangent, we know tangent, that one's one of our main ones anyways. So when sine is negative or less than 0, so we're saying sine is negative, and then tangent is greater than or equal to 0, so it's tangent's positive. So when sine is negative, that would be down here, these two. So between 3 and 4. But then tangent has to be positive, but between these two, tangent is only positive in quadrant 3. That leaves quadrant 3 as our only option. Okay? So that's why this one's quadrant 3. Okay, just pick another random one. Tangent has to be less than 0, and sine has to be less than 0. So those are negative and negative. So again, tangent's negative in the second and the fourth quadrant. Okay, and then between those two, sine is only negative in the fourth quadrant. So that's why this one's going to be the fourth. Okay, let's just do one more. Let's see, cosine is positive, so this is greater than 0. So that could be anywhere 1 or 4, these two. Then cotangent has to be greater than 0. Well, cotangent is the same, is going to go along the same lines as tangent. So tangent has to be positive too. So cosine and tangent both positive, what can only happen in the first quadrant. So that's why this one would be the first quadrant. Oh, I forgot to circle my answers. There we go. Okay. Section 7. This one, find the values of the other 5 trig functions. So this is just like what we did up here, except that now we're given one of the trig functions instead. We're given one of the trig functions instead, and then we actually have to kind of extrapolate from there. So cosine of theta is negative 3 over 5. So really what this is saying is that, well, x is equal to the negative 3 and r is equal to the 5. Okay. The other key feature here is they say that it's in quadrant 2. So when I draw my situation, I know I'm going to be in quadrant 2, which is over here. Okay. So I can draw what I know. I know that, there's my theta, there we go. If I know that x is negative 3 and r is 5, oh, by the way, r is always positive. Okay. Then I need to figure out what's y going to be. So if that's my x, this is my r, then I need to find y. Okay, again, we've got a 3, 4, 5 triangle, so this is just 4. Okay, so now that I know that that's 3, 4, 5, I can find the rest of them. So I have cosine, I can find sine. Sine is just y over r, so it'd be 4 over 5. I already know cosine, they gave that to me, so tangent would be y over x, so that would be 4 over negative 3. Let's see, cotangent would be the opposite of that, that'd be 3 over 4. Secant is going to be r over x, and then we have cosecant theta, which would be r over y. Okay, again, always draw these, okay? Like over here, this zero, our angle theta is between 0 and pi over 2. This is quadrant 1. Right, between 0 and pi over 2. The other thing to keep in mind with this one, before you try it, is that this is 3 over 1. Okay, so it's a hot tip. If there's no fraction, make it 1. Okay, so it's over 1. So that means that 3 is my y, and 1 is my x. Okay, so that should be helpful for that one. All right, let's just go down to section 8, talk about some of these true-false. This is just true-false, just using some of the properties. Okay, like this first one, this is the definition of an odd function, where you have a negative angle and then that negative comes out. This is true because of sign being odd. Okay, let's see. We can do, let's just pick a random one, cosine of 120 and negative cosine of 60. Well, cosine of 120, that's really 2 pi over 3, so it's my over 3 family. So that would be, let's see, what would that be? That would be negative 1/2, because it would be in the second quadrant where cosine is negative. So that's negative 1/2. And then negative cosine of 60, well, that's negative, and then cosine of 60, that's pi over 3. So it's first quadrant, so it's going to be positive, so it's 1/2. Negative 1/2 equals negative 1/2. True. Okay? I mean, we can, you can use symmetry, you can properties, you can do things like that to figure out whether or not these are true or false. Like 43, for example. 390, that's not one of our special angles, but it's bigger than 360, so we can go ahead and take away 360. So that's cosine of 30 equals cosine of 60. But then we know that cosine of 30 is root 3 over 2, and then that one's going to be equal to 1/2, so this one's false.